back to it and watch it again. These are long process-driven problems. All right, and it's called linear programming, and I'm starting off just showing you an example without talking about the process here. Just here's an example, and this is not a good example because they've already done all the work for you and you're just looking at a graph. In a minute, we're going to get to the problems that matter to me, and you'll see that they're long, paragraph-long problems, word problems. So in this situation, in red is what you're going to be starting with. And they're just asking you to graph this system of inequalities. Now, we turned them into equations to graph the boundaries here, but that was just for a matter of convenience, so you wouldn't need to show that. We're going to graph this, 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 and this. If you look at x is greater than or equal to 0 and y is greater than or equal to 0, where do you live if those are the two of your inequalities? Better known as? Better known as? First quadrant. Okay, you're in quadrant 1. If x is positive and y is positive, we're in quadrant 1 somewhere. Those two constraints, these are going to be called constraints in a little bit. These two, oftentimes in the word problems, you'll hear me refer to those as common sense constraints. You still need to include them, but they're going to be no-brainer constraints. Like you're manufacturing stuffed lions and stuffed giraffes. You cannot have a negative number of lions made or a negative number of giraffes made. So you say, got to be positive. X is greater than or equal to 0, y is greater than or equal to 0. Everybody understands that, I think, at a very core level. But nonetheless, we still have to say it as a constraint. Then you have this constraint, y is less than or equal to negative 2x plus 5, and you can see that's the purple graph here, and it's shaded down. And y is less than or equal to negative 4x plus 8. Y-intercept is 8 on the red graph, down 4, right 1, down 4, right 1. That's the red graph, and again, shaded towards the origin. Now, just like last night's assignment, which is really what this is, the overlap region is shaded, in this case, in yellow. So the overlap of these four inequalities would be this yellow quadrilateral. The things that we're going to want to know are the corners. There are 4 corners. And one of them has not been marked for you, so we want to make sure that you realize that there are 4 corners for that. We have this corner, this corner, this corner, and this corner. Does everyone see that? Those 4 corners are going to be very important for you when you're doing these word problems, and I'll get to why in just a moment. These problems, like I said, very time-consuming. You'll have one on the test. And this is the process that you're going to be going through to doing these linear programming problems. And some of you are going to say, whoa, I'm not doing that. I'm going to mark you down for these, because everything's going to have points allocated to it. First thing you're going to do is define variables. What will that sound like? Let x equal whatever, the number of lions. Let y equal the number of giraffes. Or better, let L equal the number of lions and G equal the number of giraffes. But you need to define the variables. Write the constraints as a system of inequalities. That means just write what we saw on that example up above. Give me all the constraints. Constraints are limitations. A constraint is nothing more than a limitation in your problem. In the lions and giraffes problem, this is an old problem from the integrated series. In the lions and giraffes, you were manufacturing them, and you needed a certain amount of special plastic tubing to make the legs of lions and you needed obviously more of that special tubing to make the legs of a giraffe. You also needed yellow cloth to make both of them. In the yellow cloth, you needed a certain amount for lions and a certain amount for giraffes. And so you would use all that information to write these limitations as inequality statements. Once you have the limitations written, you want to graph them and find the overlapping region of shading. It'll be a polygon typically. And you need to make sure you determine what the coordinates of the corners of that polygon is. And then they're going to ask you to maximize or minimize something. That's called a linear combination. And the linear combination will be written as an equation, not really. They say write it as an expression. We're going to write it as a function in two variables to describe what you're maximizing or minimizing. Oftentimes it's profit or income or minimized income or expenses or something along those lines. And then you're going to take the corners of your feasible region. This overlapped polygon is called the feasible region. The corners are what you're going to plug into that linear combination, what you're trying to maximize or minimize. And I'll explain why you're going to do the corners here in a minute. And then answer the question by selecting the greatest or least result. Take the ordered pair that generates either the greatest if you're looking for a maximum or the smallest if you're looking for a minimum. Now, like I said, I'm going to go through a couple of things here, but before we look at examples, let me just explain to you why we're picking the corners. Has everyone got these 6 here? Everyone feel okay with that? It's the same process you're typically going through when you do these word problems. But what I need you to realize is that the corner point principle tells us that if you're trying to maximize or minimize a linear combination, that combination, whatever it is, whatever that, in this case, P equals, or P of x comma y would equal ax plus by. If there is a maximum or minimum, it will occur at one of the corners of your feasible region, and there's no way that that won't happen if it's a linear combination. Okay? So the corner point principle tells you don't have to check anything else. It's going to happen at a corner when you're maximizing and minimizing. Now I'm going to go through, and I don't want you to copy these down. I want you to just watch for the next few minutes. And I'm just going to show you quickly the 2 problems we did last period. And then we'll go ahead and we'll go through a couple of problems. That way all the problems will be done and you'll have those all online. You can go back and look at them as you see necessary. So in this particular example that we started with, it was a factory producing short sleeve and long sleeve shirts. Notice I went through, there's a lot of fluff in here. You want to get down to the nuts and bolts, as it were, or some people even list out all the important facts. So short sleeve shirts, 30 minutes of labor. Long sleeve shirts, 45 minutes of labor. Total of 240 hours of labor are available for you each day. That probably means they have 30 employees type of thing at 8 hours a day. Doesn't really matter. We want to find out what's the maximum number of shirts that we can, the maximum number of shirts that they can be packaged each day is 400. So it's silly to make more than 400, otherwise they're just going to be piling up. So we're going to make a maximum of 400 shirts. And then they tell you about profit, $11 and $16. So we want to find out how many shirts you're going to make to maximize your profit. So our unknowns were how many shirts. L is long sleeve, H is short sleeve. I can't use S's typically because they look too much like 5s. It's my own personal problem, not yours. The common sense constraints, we got to include them. L and H both have to be greater than or equal to 0. The total number of shirts has to be less than or equal to 400. Now again, these are inequalities. They have to be less than or equal to 400. We can come in to work one day and the manager could say, you know what, we're not making shirts today, we're going to go out and play softball. Cool. What's your profit going to be? 0. But that's okay. We made less than or equal to 400 shirts. It's all good. It's going to take 30 minutes and 45 minutes to make each shirt. But the total time that we have is in hours. So we had to change minutes to the same unit as the total. Or you would have had to change the total to minutes, either way. So 1/2 times H plus 3/4 times L would be less than or equal to 240. Those are your 4 constraints in this problem. Could be 6, could be 8, could be 3. Okay? Could be 2, I guess. The thing that we're trying to maximize is profit. Profit for H comma L is 11H plus 16L. That's your linear combination. So the next thing you're going to want to do is you're going to want to graph your constraints, which we did here. We're in quadrant 1, where I use diagonal zeros and cover-up math because both of those are in standard form. And I got the red line and the blue line, and they both shade down. So the overlap is just like this. Easy to identify the first 3 corners, 0, 0, 0, 320, and 400, 0. The fourth corner, harder to identify because my graph isn't super accurate, and I don't think too many people's will be. Hard to do 0, 320, 0, 400. So in order to find this point, we take the red lines equation and the blue lines as equations, and we solve the system. So H plus L equals 400, and then I multiplied this by 4 to get 2H plus 3L is equal to 960, so I didn't have to work with the fractions. I'm doing the elimination method. And when we combine, or we multiply this by -2 and add these two, we get L is equal to 160. When you plug the L into the H plus L equation, you get H is 240. So that's where the fourth corner, 240, 160 comes from. You just solved the system of the 2 intersecting lines that created that point. Next thing you're going to want to do is you're going to want to list your corners in a little table. This is H comma L for my corners. This is my profit expression, and then this is the profit of H comma L. So we're going to plug in 0, 0, 400, 0, 0, 320, and 240, 160 to see which one gives you the most profit. So obviously we have no profit. We don't have to show anything for 0, 0. All you need to show me to get the profit is this, that you plug this in, and on your calculator you can do this in one shot. It will take you 5 seconds to do that. And you get 4,400 for the first one, 5,120 for the second one, and 5,200 for the third. Kelly?
Where did you get the precision 11H?
That was in the question. So right here, if the profit on a long sleeve shirt and a short sleeve shirt, short and then long are 11 and 16 respectively, that's where that profit function came from right here. So 11 times the number of short sleeve plus 16 times the number of long sleeve will give me the total profit. Okay? And that one will be the most obvious to you when you're doing these problems. It'll just say, oh, I know what I'm maximizing. Easy. All right, so then clearly the highest profit occurs here at 5,200 per day, 240 times in 160. So make 240 short sleeve shirts, 160 long sleeve shirts for a profit of $5,200. You need to write that out in a sentence. Okay? What you're seeing up here is the minimum amount of work I would expect. I don't think you could show me less and get full credit. Okay? Very well answered last period. Explain why the factory manager might decide to produce different numbers of shirts than the one that maximizes profit. If you're the manager, why would you ever say, is there a reason that you can think of where you should say, let's not make 240 and 160, 240 short and 160 long? Can you think of something? Or
It's like summertime, so
great idea. We're not going to make a lot of long sleeve t-shirts in July, or imagine August in Sacramento. That's not a good reason. So they may say, we're going to make, because it doesn't do you any good to make them if you can't sell them. I love when people say, yeah, I got this baseball card, it's worth $800,000. How do you know that? And the only time it's worth $800,000 is when I give it to someone and they give me $800,000. Okay, if you can only sell it for $12, it's only worth $12. Sorry.
Do you have to use like a clear example, or can you just say like the principles of supply and demand? That's what.
You can use anything that I understand.
Does that make sense?
No.
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 Really?
Yeah. When I grade up a
Yes,
moron.
answer. That's like saying that even if it's the perfect time to make long sleeve shirts because it's winter, well, people don't really want to buy them because they're not.
I know that you're telling me the same thing that he's saying.
Yes.
Good.
Hey.
Tell it to the 5-year-old who's grading your test. Okay, that's what I want you to keep in mind. Whenever you're doing an explanation, and you're not using terminology that's from our class, you need to explain it very clearly. And again, this B question is just that. It's just an add-on type of question. Okay? So you've got the idea. Is there a right answer for this? I don't think so. I think that's a good answer. Yours is a good answer. Kevin, did you have a different one? Okay. So let me show you the other problem that we did today. This one was a little bit different. This was a minimized problem, and that's why I want to make sure you see this one as well. This is a hospital is hiring nurses, and they give you the salary for a nurse, and for each nurse, they're also hiring nurses' aides. Okay, they have to have nurses' aides for every nurse. It doesn't do you good to have one without the other. And there's all kinds of limitations here. Some of them are federal regulations or state regulations you have to meet, but here's the drill. You can hire 50 people, but you have to hire at least 20 to function properly. So you can't hire 10 to save money. You don't have enough people then to function. But the most you can hire is 50. The nurse wants at least 12 aides. Whatever. She's the one making the decisions. You still need 12 aides, at least. Minimum of 12. But the number of nurses has to be at least twice the number of aides to meet those state regulations. The question is going to be, how many nurses, how many aides should you hire to minimize your salary costs? Yeah. So again, same drill. We had our let statement was done by someone very creative in the second example. X is the number of nurses. Y was the number of nurses' aides. I think I would have picked N and A. That's just me. Okay? I like the letters to remind me what I'm dealing with, because I have to always go back to this for extra time. Total number of people hired, less than or equal to 50. Total number of people hired, more than or equal to 20. Total number of nurses' aides, more than or equal to 12, which means the total number of nurses is greater than or equal to double the number of nurses' aides. And sometimes we'll screw that one up and put Y is greater than or equal to 2X. You've got to be really careful with that. When you're not sure if you did it right, pick a number for X. 20, Y is 10. 20 for nurses, 10 for nurses' aides, that's the right way to go. If it goes the other way, where you had 20 for nurses' aides and 10 for nurses, that's wrong. It doesn't work correctly. The two common sense constraints, we can't have a negative number of either higher. And albeit in this example, these don't matter, they still need to be included. This one, these don't make any difference. They're not even, you don't have any worry down here. But you do end up in quadrant one. But these three constraints that you have, the black, the green, and the red, take care of everything. In fact, this blue one doesn't matter either. Okay. So then you graph all your constraints. X plus y is greater than or equal to 50 is the green. X plus y is greater than or equal to 20 is the blue. And that would shade in between. But then when you graph the other two, y is greater than or equal to 12, that's the red shaded up. And then x is greater than or equal to 2y, it turns out to be this black one shaded down. You end up with this triangle. Now what you do know here on these points, these three corners, we knew that this had to be something comma 12. This also had to be something comma 12. So I took the 12 and I plugged it into each of these equations. So when you put in the 12 for y, you get 24 for x, right here. And when you plug the 12 in here, you get 38 for x on the green line. So that's where the two intersections are here. This corner, we had to do substitution again, or elimination, or whatever. X plus y equals 15, x equals 2y. We substituted in for the x, solved for y, and we got 50 over 3. And we plugged in the y and got 100 over 3 for the x. So the third corner, 100 over 3, 50 over 3. Here's my three corners. Salary is $35,000 for the nurses, $18,000 for the nurses' aides. So your salary for x comma y is 35,000x and 18,000y. The plugins gave us nice, pretty numbers: 1,000,000, 1.5056 million, 1.466 million, 1.546 million. Be careful that you're answering the right question, because most of these problems are asking for the maximum. Not this one. This one is asking to minimize salary. We have to minimize our costs. So we don't want to take the 1.546 million, that's the most. We want the smallest. Where does that occur? When we hire 24 nurses and 12 nurses' aides. That's going to meet all our requirements. We can still open, we have enough people, we have the right ratios for the state, and we're all good. Okay, so you've got the Reader's Digest version for those two. Does anybody have any questions on it? These two you might want to go back and look at. I'll put them online and you can go through and do them. Just cover up the rest and see how you make out.
Just somehow you got a block, right?
This one right here?
Yeah.
The number of nurses has to be more than double the number of nurses' aides. So if x is greater than or equal to 2y, I just made a t-chart. When x is 10, y is 5. When x is 20, y is 10. When x is 40, y is 20. And I just plotted those points. Okay, you can use slope. You can figure out what the slope is a half. So your rise and run is 1, right 1 up 2. But again, the numbers don't really work very well. You're not going to have right 1 up 2. It's too hard to do because the numbers are so big.
So you always wanted to cover the map.
Well, if it's in standard form, I did, but when this wasn't in standard form. In standard form would only give you the x-intercept. X and y-intercept is 0, 0. It doesn't give you any other points, so I just picked another point. I know it went through 0, 0, so do 50, 25. Okay, I just made a t-chart and I listed out there's 4 points for it. It doesn't matter to me how you graph.
Is there another question to this problem, or is it just...
Nope, that was all they asked.
Okay.
So when I answered this, they only asked, they said, so hire 24 nurses and 12 aides for a minimum salary of $1.056 million. And I'm not exactly sure, so how many nurses and nurses' aides should be hired to minimize? That's how you answer the question. Okay. And they could ask you something else, I don't know what that would be. If they did. Any other questions on this?
I have a question about the equation that x is greater than 2y.
Yep.
Does it say you need twice many nurses?
As nurses age, right?
Yeah, so when it,
It's,
should the x have 2?
so that's what I was talking about. So you like 2x is greater than or equal to y,
Yeah.
okay? So let's say that you had 20 nurses. According to this, how many nurses aides would you create? If you put in a 20 for x, what's y?
0. So put in,
Put in a
sorry,
20 for x. So y is 40. You have 40 aides and 20 nurses. Do you have twice as many nurses as aides? No. And this is the kind of thing, honestly, I sit there and I go, God, I hate these. It's like a brain teaser. So what I literally do once I get to here is I say, okay, if I put in a 10 here, this has to be 5. 10 nurses, 5 aides, that's the right way. If I wrote this first, when I put in a 10 here, I get 20 here, that didn't work, so I don't want to do that. Okay? So you're right with me. You're in my boat. Not the best boat to be in for that. What else?
How did you come up with those two equations?
All those two.
No, those two. The two
Which
below,
two?
The two below the x plus y greater than or equal to 20.
I read it. The head nurse wants at least 12 aides. What variable is the aides?
The aides are y.
The aides are y. So y has to be at least 12. How do we say that? Y is greater than or equal to 12.
Okay.
Right?
Yeah.
Okay. And then what else? It says according to the state, the number of nurses has to be twice the number of aides. Number of nurses has to be twice the number of aides.
Right.
So that's where the one that Kevin and I were just talking about, the number of nurses is twice the number of aides. X is greater than or equal to 2y.
Yeah. Then how did you use those to get your answer?
I graphed them. So x plus y is less than or equal to 50 is the green line.
Okay.
X plus y is greater than or equal to 20 is the blue line, and that would be shaded so that you'd have that trapezoid. And then y is greater than or equal to 12 is the red shaded up. And then x is greater than or equal to 2y is the black shaded down. And then x is greater than or equal to 0, y is greater than or equal to 0, just gets you to quadrant 1. The overlap is this triangle.
So the numbers are in between there.
What numbers?
The answer, amount of aides and nurses.
That, well, the number of nurses and aides is all over this. But the ones that meet all of the restrictions, the constraints, are in this triangle. You know, we can hire 25 nurses and 25 nurses and like 12 aides would be part of that. You know, there's all kinds of things that will work for us, but only these three would minimize your expenses. Has to happen at a corner. Okay? Following that? There should be one more question somebody should be asking before we go to the problems we're going to look at. There's one that should kind of jump out at you that you should be asking even though it didn't affect our answer. Does anyone see anything that's particularly bothersome
In blue line.
for what we did?
Blue line.
What about it?
Does it do anything?
It doesn't, and neither do these two constraints either. They get washed out by the other three. But they're still legit. But it's something else. There's something else that should be troublesome as far as answers go. Imagine if this were the answer.
What happens if there's fractions in the answer?
Then you're in trouble, right? If this were the corner where we minimized our salary expense, what would you say is your answer? You can't say 33 1/3 and 16 2/3. that's ridiculous. Well, okay, you could then potentially say that, I kind of like that as a response. So maybe you could interpret as part-time, that's pretty good. Okay, so somebody only wants to work 2/3 of the time, and another person only wants to work 1/3 of the time. So that's a pretty good response. But if you're not going to tweak it that way, you certainly can't round. We can't make this 33 and this 17 because then we're not meeting the state requirement. So I don't have a great answer for that. Hopefully that won't happen. The reality is you can't give that as your answer.
So we should take the next one like.
Well, that's what I'm saying. You can't just round.
So are we gonna get a problem where it requires us to?
I hope not. I can't guarantee that you will or won't because I haven't done all these problems. This is the first time we're going through this section.
Okay.
So I don't know what you're going to see. The answers in my book for the problems I'm asking you to do don't do that.
What are they on the test?
The one on the test I haven't done out, I haven't worked it out, but hopefully it won't come out. You need to be able to answer that question, so you have to improvise. You need to adapt. It's summertime. We're not selling long sleeve shirts. We're going to have one person as a nurse working part-time and one part-time. That would be a legitimate answer. You could give that answer and you could even say, this doesn't make sense as an answer, but this is the corner, these are the points that gave us the correct minimum salary. Explain it. Tell me that you're confused. There's nothing wrong with that. And if you can't see a way out, I'm fine with that. Explain why you're confused.
Can you explain the black line again? I know you.
Number of nurses is twice the number of aides.
I got that.
That is the black
It's just that
line.
graph.
How would you graph it? I mean, we've been graphing lines since you were in 6th grade. So let's not make it confusing. I'm not trying to make it confusing. I went old school in managing chart. If y is 5, what's x? If y is 10, what's x? That's what I did. And then I plotted those points. 10, 5 is right here. 20, 10 is right here. Right here. 40, 20 is right here. 60, 30 is right here. And I connected the dots. Okay? Don't overthink simple things. Okay? You're overthinking this because it's not in a form. If you want to put it in slope-intercept form, divide by 2. Y equals a half x. And then you can graph using slope and intercept. Okay? Don't overthink it.
So you solve the system 3 times to get the solutions to
I
find
didn't. Well, yes, I did. But I didn't have to solve the system. I could do that because I knew on the red line everybody is something comma 12. To find this, if I know this is comma 12, plug it into the green line. Find out that x is 38. If I know this is something comma 12, plug it into the black line for the y is 12, and x has got to be 24. 24 plus. The other one where the green and the black meet, I have to do elimination method. Or actually I use substitution. Okay? So those 2 problems we did last period, and we worked them out. So I want to show you, we want to go through and work out and see what happens. Okay? So we're looking at this one, and again, I haven't done this. I think it comes out okay though. So, but let's take a look. So you have a lot of information. You want to try to narrow it down. So we look at a diet is to include at least 140 of vitamin A. At least 145 of vitamin B. Those are constraints. These requirements can be attained from 2 types of food. Type X, very creative, contains 10 milligrams of vitamin A and 20 milligrams of vitamin B per pound. Type Y contains 30 milligrams of vitamin A and 15 milligrams of vitamin B per pound. Type X costs $12 purchase to satisfy the requirements at minimum cost. So lots of stuff going on in this problem. But we gotta figure out, thank you for inviting that. No. We're gonna start with a let statement. What do you wanna let? A equal vitamin A? That's a very vague let statement. Doesn't tell me anything.
Let A equal at least 140 milligrams of vitamin A.
Nope. Good guess though. Look at the question. That tells you what to let. That's not part of the question. So I would definitely wouldn't do that. Look at the question mark. That's what I mean by the question. Find the question mark. Let x equal, what about type x? Read the question. Yeah, it doesn't ask you to do that. It doesn't ask you to get any, you're not buying vitamin A. Read the entire question, starting with the word how. That tells you what to let.
Let A equal how many pounds of type X?
Why would you let A equal the number of pounds of type X food? What could we use that might be a little better? Oh, that's a great idea. Let X equal number of pounds of, what do they call it? Type X food, right? Type X. No, type X. It doesn't even tell you what you get. Type X. And it's a food. They're not telling you what it is. What else should I let? Let Y equal number of pounds of type Y. That's your let statement. Now, there are a boatload of constraints in here. Okay? You have a lot of constraints, but they all have to be based on how many pounds of each type of food you are using. Okay? Tell me a constraint.
Y is greater than equal to 0.
Why do you, oh, so we're going common sense?
And the X is 0.
Attaboy, way to get those out of the way. You want to have those out of the way for sure. X and Y have to be greater than or equal to 0. Back to first period for me again. Come on now. Kevin?
Want to be X greater than or equal to 140?
X is not greater than or equal to 140.
X plus Y greater than or equal to, no.
No, it really, you're getting worked up over letters in
It's on the
you need at least 140 milligrams of vitamin A. Where are you getting vitamin A from? Right, how much from type X food do you get? Not X plus Y. Not X times Y. type food X, for every pound you eat, how many milligrams of vitamin A are you getting? 10. So how many pounds of the food X are you eating? Read. Right here. Read.
Getting X.
You're getting X pounds of that. And for every pound, how many milligrams of vitamin A are you getting? So how many milligrams of vitamin A are you getting from this food? If you get 1 pound, if you get 1 pound of food X, how many milligrams of vitamin A did you get? 10. If you got 2 pounds, 20. If you got 3 pounds, how many pounds are we getting? X. So how many milligrams are we getting from food X? 10X. Wow. Yes, some of you said that, but let's not be doing a touchdown dance. You said some of the other things too. How many milligrams are you getting from the Y food for vitamin A? So, what do we do with that? Plus 30Y. It has to have at least 140 milligrams of vitamin A. Greater than or equal to 140. What's another constraint?
30x plus 20x plus
20x plus 15y is greater than or equal to 145. That's vitamin B. This is vitamin A. This is vitamin B. Are there any other facts up here that we haven't used yet? The cost. Are there any others besides the cost? Is there anything else we haven't dealt with? So that's it. Those are our 4 constraints. Now, we're going to minimize cost. So we want a cost based on our XY values to be equal to, what will the cost be? 12x plus 8y would be your cost. Okay, so you have 4 constraints in one linear combination that you're trying to minimize. You want a minimum here. Right? So now we want to sketch out what's going to happen. Common sense constraints put us where? In the first quadrant. 10x plus 30y, if we graph that, I'm going to find the intercepts. If we solve for y, you're going to get 14 over 3. If you solve for x, you're going to get 14. So 14, 0, and 14 over 3, which would be 4 2/3. Which way do I shade? Towards 0, 0, or away? Away. So we're going to be shading up here. 20x plus 15y, 145. X and y, 0, 0. When you put in the 0 for the x, if you divide 145 by 15, not 4. It's definitely not 3.
So we went 29 over plus.
It doesn't work, right? So 29 over 3. And when you solve for the x, another ugly number, 145 over 20, what does that reduce to? 29 over 4, another hill. So 0, almost 10. That's 29 over 3. And 29 over 4, which would be a little bit more than 7. Would feasible region is an open region here, not a polygon. And the thing I hate about these problems is because you only have these 4 constraints, I'm willing to bet you that that's going to be what minimizes us right there. I'm just guessing. Right. Who knows? This one, we can have fractional answers. It's legitimate to say you can have fractional amounts of a certain food. That's fine. So we got to figure out where these two lines cross. So 10x plus 30y equals 140, and 20x plus 15y is equal to 145. How do you want to solve the system? What method? Elimination. Which variable do you want to get rid of? X. So we're going to multiply this equation by -2. So you're going to get negative 20x minus 60y is equal to negative 280. And when I add these two equations together, the x's disappear. You get negative 45y. And when you add 145 into negative 280, is that 135? Negative 135, how pretty. When we divide by 45, y is going to equal 3. How do I figure out what x is? Plug into one of the two originals. So if we do the first one, you're going to have 10x plus 30 times 3 equals 140. That means 10x is equal to 50, so x is, look at how pretty that's going to be. 5, 3. Look at that. So now we know our 3 corners. 14, 0, 5, 3, and 0, 29 thirds. So 0, 29 over 3. So you're only going to eat food y if you do that. 5, 3, and 14, 0. And our cost is 12x plus 8y. So this is C of xy. So you're going to want to plug in 12 times 0 plus 8 times 29 over 3. What's 8 times 29 over 3 equal? 77.3. So $77.33. Then we're going to have 12 times 5 plus 8 times 3. 84. Whoa, surprise. And then you have 12 times 14 and 8 times 0. How much is that? 168. So as it turns out, we should buy 0 pounds of food X and 9 2/3 pounds of food Y. So look at that. Questions? One that we can look at, this is like the shirts, more like the shirts. And you have a bread company makes 2 types of wheat bread, light whole wheat and regular whole wheat. A loaf of the light whole wheat bread needs 2 cups of flour and an egg. A loaf of the regular, 3 cups of flour and 2 eggs. They only have 90 cups of flour and 80 eggs on hand. The profit for the light is $1, and the regular is $1.50. So this is a fastball right down the middle. This is not confusing at all. Okay, there's no misdirection. Right? So when we look here and we say, so if we're talking about the light, okay? So light, you need 2 cups of flour, 1 egg. The regular whole wheat is 3 cups of flour, 2 eggs. Okay? Then you've got to look at how we're breaking this down. We got flour, flour, and flour. Those 3 are going to go together. And then you've got your eggs, 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 and eggs. Those 3 are going to go together. The stuff at the bottom, right here, the money deal, that's going to be what your linear combination is that you're maximizing. Let's start with what we're trying to figure out. So let's start with the let statement. Let's let. What do you want to let? What about the light whole wheat bread? Be specific. The number of loaves. So let L equal number of loaves of light whole wheat bread. What else? R. Number of what? Loaves. Regular whole wheat bread. Right? So now we have our variables L and R. There are 4 constraints that I think that I spotted. There are 4 constraints. But for us, we're going to use, you're the one who picked it. So the common sense constraints, L is greater than or equal to 0, R is greater than or equal to 0. Got to have those. Now how about the others? We need a flour constraint.
12 is 3 orders less than or equal to 90.
That's the flour constraint. 2 cups, 3 cups, has to be less than a total of 90. And how about the egg constraint? So L plus 2R less than or equal to 80. Those are your constraints. Everybody seeing that? What should I do next? Okay, so in this case, what are we trying to do? Maximize profit. So we want to do profit based on L comma R. What is that profit going to equal? Not L, L plus 150R, is that what you said? 1L plus 150R, 1.5R. Very good. What's next? Sketch a graph. And the graphs really are sketches. They're just to help you see what's going on. Okay, so here's our sketch. Remember, alphabetical order for me, you can do it whatever way you want, but if it's L's and R's, L comes first, so that's horizontal. R comes second, that's vertical. That way I'm always consistent with how I set up my axes. The common sense constraints put you in quadrant 1. Can't worry too much about those. 2L plus 3R is less than or equal to 90. L and R, diagonal zeros. If we put in the 0 for L, what's R? 30. If you put in the 0 for R, L is 45. So 0, 30. And 45, 0. There's your constraint. Would we shade down or up on this one? Towards the 0, 0 or away? Towards the 0, 0. 0, if you plug these 0 and 0, that's going to be a true statement. L plus 2R is less than or equal to 80. Again, standard form, L and R, diagonal zeros. If you put in a 0 for L, what's R? 40. If you put in a 0 for R, what's L? 80. So you're going to be at 0, 40. And 80, 0. The overlap of the two shadings is really going to be this. So the green shading is irrelevant to us. In our corners are at 0, 0, 45, 0, and 0, 30. Well, there's a system of inequalities. So those are the ones that you're going to check when we plug in. So L plus 1.5R to get your profit of L and R. We're going to plug in 0, 0. We're going to plug in 0, 30. And we're going to plug in 45, 0. You're not going to get any profit when you don't make anything. 0 plus 1.5 times 30 gives you how much profit? 45. 45 plus 1.5 times 0, also 45. Now, see if you can answer the question. The question is, how many loaves of each should you make to maximize your profit? How many loaves of each should you make to maximize your profit? So, how many loaves? That doesn't help me. I got to tell my people, we got to make some bread here. How many do I tell them to make? Nope, didn't say. I haven't checked this, but I have an answer. Why is that? The question is, how many loaves do I make that will maximize my profit? Okay. So 0, 30 would be better. You want to make 30 regular loaves and you're good.
Yeah.
Right?
Couldn't it just be a 4?
give me the ore. 30 loaves of the regular wheat bread. Or, okay. Anybody else?
27
The light ones. And how did you come up with those numbers? Of this? And what was your profit? And then in a minute, well, you can enlighten me on something else. But so you wanted to use 27.5. You sure that's the halfway point?
Yeah, 2.5.
Let's go with 22 and a half, comma 15. What would your profit be on that? 22 and a half and 15. Really?
Yeah, 45.
The calculators cost pretty hard. 22 point on your calculator. Do you have a calculator?
Yeah.
Multifunction?
Yeah.
22.5 plus 1.5 parenthesis 15 close parenthesis. Yeah, what? 45. So my hypothesis was any number of loaves you make that are on this red line, it's going to give you the same profit. This is weird. This shouldn't be happening like this for a linear programming problem. Right? But any one of those would work. I like Mitchell. Less is more, right? Less is the way to go. So 0.30, that's the smallest number of loaves we could make, perhaps. That's probably the way to go. But anything, and again, 22 and a half loaves, seriously? What's that last loaf looking like? You only filled it up halfway, so it's a short, long loaf? Yeah, but that's not what this is all about. You have to sell loaves of bread. Right?
You could sell it to last.
All right, so this is the 3 that I'm asking you to do tonight. Yeah, look how long these take. So I'm only giving you 3. The answer to number 12, which is probably not in the back of your book, is 56 and 8. The answer for number 12, I think, is 56 and 8. The other one, 9 and 11, should be in the back of your book. 9 is kind of